All right, so in this problem, it says a new ride spins you in a vertical circle of radius 9 meters so that it makes one revolution every 4.8 seconds. Now, one revolution in 4.8 seconds, I'm not sure whether that's going to be so fast that it's going to pull me off the ride or whether I'm still going to be on the seat when I reach the highest point on this ride, because that would be the place where I'm most likely to fly off the ride. So it says if you weigh 835 newtons, what would be the force that the seatbelt needs to apply? So if they're saying it's a seatbelt, then I'm going to assume that I do need a seatbelt at the highest point, because that's where I'm going to come off the ride. So if I'm going to write my picture, I know that my weight is going to be down, but I'm going to say in this problem that the normal force is also down. So I'm going to call that the weight, and I'm going to call that the normal force. So if the normal force is due to the seat belt, it would be in that direction. If the normal force is due to the seat, then it would be up. And a lot of times you can't tell just by looking at one revolution in 4.8 seconds. That might be fast. That might not be fast at all if the radius is small, or that might be very fast if the radius is big. So you take a guess, and if you're right, your answer will come out to be positive. If you guess wrong, it will be negative. Don't change anything. Don't change your picture, and don't change the sign of your answer. Just leave it. And if the picture, let's say for example, if this answer comes out to be negative, then what that means is the arrow is up. But if I see down, I'm going to expect to see a negative answer for your normal force if it was supposed to be up. So the first thing you're going to do once you have the picture is what would be the force that the seatbelt needs to apply. So we're going to write our descriptive equation. So when we sum up the centripetal forces, I'm going to have two forces directed towards the center of the circle, Fn plus W. Now that's either going to equal mv squared over r or mr omega squared. They didn't give me the rate. They didn't give me the angular velocity in radians per second, and they're not asking me to solve for the radius. So I'm going to use mv squared over r. And if I'm rearranging this equation to solve for the normal force, which would represent the force that the seatbelt applies, I just need to move the w to the other side. So it's going to be mv squared over r. Now, if they gave me the mass, I would replace weight with mg. But they didn't. They gave me the weight, so I'll leave it as w. So now all I need to do is use my equation as a checklist to see what I know and what I still need to calculate. The mass is not given, so I am going to use the weight to get the mass. The radius is given. It's given as 9 meters. And they didn't give me the v, but they told me it makes one revolution every 4.8 seconds, so I'm going to get the v from that. So I have a couple things that I'm going to have to solve for so that I can plug into this equation right here. So I need to get the mass. So the mass is going to be W over G. So the weight is 835 newtons. And gravity is 9.8 meters per second squared. So what do you get when you divide 835 by 9.8? 85.2 kilograms. And the other thing that I need to solve for, I guess I'll do it over here. So the other thing I need to solve for is V. So my starting point is it makes one revolution every 4.8 seconds. So I have one rev every 4.8 seconds. All of these V and omega and T conversions, I used to actually have a chart where I had, in fact, I have it here somewhere. Let me see if I can actually get to it. Well, I better not. I don't want to stop the podcast, but I'll show it after this. So in one step, I can go from revolutions per second to meters per second. So I'm going to go revs. I'm going to go revs to meters. One revolution, I'm going to move through the circumference of the circle. So that's 2 pi times the radius, which is 9 meters. So if you solve that, what do you get for the V? 11 point, what? 7? What's after the 7? 8, so 11.8. So 11.8 meters per second. So now I have everything. I just plug into the equation, and that's going to be my answer. So for part A, the seat belt is going to, I'm going to put in mv squared divided by r minus w. Now w was 835 newtons. The mass was 85.2 kilograms. V is 11.8 meters per second. And the radius is 9 meters. So, plugging in those numbers, and what do you get? $483? 483 newtons. So there's your answer for part A. And then for part B, usually it's the part B question that's the tricky one, because sometimes that you have to know, well, where do we put the object to then figure it out. It says, what's the maximum velocity allowable to eliminate the need for a seatbelt? So the seatbelt is needed at 12 o'clock. So, thank you. So to eliminate the need for a seatbelt, I am going to, and I'll do it in a different color since I'm doing part B, but I'm going to make this 0 because that's the maximum velocity allowable to eliminate the need. If I go any faster than the maximum, then I need a seatbelt. So if the only force changing the direction is my weight, then that's going to be my maximum allowable. So I have the same equation. The equation is the same. All I need to do is I'm going to eliminate in this equation. I'm making that 0. So my equation is W equals mv squared over r, and I'm going to be solving for the velocity. So in part B, I'm going to have that the weight equals mv squared over r. Now I have the m already on the board, so I'm going to replace w with mg. And so the m's cancel out. And if I rearrange this equation to solve for v, I just need to move the r over there and take the square root. So the maximum velocity is going to be the square root of gr. Plug in the numbers, and that will be your answer. That's the maximum velocity. Anything higher than that, and I'm going to need a seatbelt. So v equals the square root of 9.8 and the radius was 9 meters. And so my number is going to be somewhere between 9.8 and 9. I'm taking the square root, so the answer was what? 9.39. And there is your answer. Any questions with that?